So previous video we have learned about block and tackle system of pulleys, is it not? So there you have to remember that depending on the number of pulleys, the velocity ratio will change. So what we have learned, if you take odd number of pulleys, then the load will be supported by the tackle. Understood? If you take odd number of pulleys, then the load will be supported by the tackle. If you take even number of pulleys, then the load will be supported by the block. What is block? What is tackle? Already I have told you. The upper pulleys which are fixed to the rigid support constitute the block, and the lower pulleys usually constitute the tackle. So if you have odd number of pulleys, yesterday's diagram I had drawn one diagram with 5 pulleys and another with the 4 pulleys. So in 5 pulleys, 3 pulleys are in the block, 2 pulleys are in the tackle. The load will be supported by the tackle. Understood? The end of the string will come to tackle. If you take even number of pulleys, then the end of the string will be attached to the block. And remember that as you increase the number of pulleys, we can increase the mechanical advantage. Understood? For a given system of pulleys, the velocity ratio will remain the same, and it depends on the number of pulleys we are using. So 5 pulleys if I am using, then the velocity ratio will be equal to 5. Then 4 pulleys if I am using, the velocity ratio will be equal to 4. So remember, velocity ratio will be equal to the number of pulleys. Understood? So yesterday we have learned about the mechanical advantage, velocity ratio, and also the efficiency of this block and tackle system of pulleys. There we have observed that the efficiency came to be 100%. Why? Because we have not considered the weight of the pulleys, and also the friction between the parts of the pulleys is neglected. So that system of pulleys is an ideal machine, and for ideal machine the efficiency will be 100%. Okay. Now we have to know what is the effect of weight on pulley, on mechanical advantage, velocity ratio, and efficiency. Now here see. Always I told you that effort will be supported by one string, and that is denoted by E is equal to T. Okay. And usually what we have written for ideal machine, N is equal to N times T. N is what? N is the number of pulleys we are using. Here, when you consider the weight of the pulley, then load will not alone be load, but it will be load plus weight of the pulley. So L plus W is equal to NT. Now L is equal to, you just simplify this transpose, L is equal to NT minus W. That is equal to N into, instead of T I am substituting E, so N of E minus W, right? Now, so what is effort? Effort is T, and what is load? Load will be equal to N E minus W. Now take mechanical advantage formula, L by E is equal to N E minus W by E. This is equal to, so E get cancelled, N minus W by E. So what we are observing, see here, mechanical advantage is less than N. So if you take ideal machine, then mechanical advantage will be equal to N, and it depends on the number of pulleys. When you consider the weight of the pulley, then the mechanical advantage is not N, it is less than N. Right? It is less than N. But however, you should remember that the velocity ratio does not change, and it depends on the number of pulleys we are using. So if you are using 5 pulleys, velocity ratio will be equal to 5. If you are using 4 pulleys, velocity ratio will be equal to 4. So in general, velocity ratio will be equal to N. So velocity ratio does not change and remains N only. So efficiency, what is happening you see here? Efficiency is equal to mechanical advantage by velocity ratio, that is equal to N minus W by E, right, divided by N. So how much it is coming? If you simplify, you will get it as 1 minus W by NE. What does it mean? Here, efficiency is not 1, it is less than 1, right? 1 minus something means what? It is less than 1. So efficiency will be decreased. It will be less than 1. So always remember, if you consider the weight of the pulley, then the mechanical advantage will decrease, but velocity ratio will not change. When mechanical advantage changes, the efficiency also changes. So what we have to keep in mind is always we have to go for weightless pulleys in the tackle. In the tackle, always we should go for weightless pulleys. If the pulleys are weightless, then we can increase the efficiency to some extent. Understood? So this is the effect of weight of pulley on all these three: mechanical advantage, velocity ratio, and also efficiency. Okay. Now let us come to some problems. Now first problem you see, a block and tackle system has 5 pulleys. If an effort of 1000 Newton is needed in the downward direction to raise a load of 4500 Newtons, calculate mechanical advantage, velocity ratio, and also efficiency. Understood? So here what is given, block and tackle system has 5 pulleys. So what does it mean? Velocity ratio is 5, right? Velocity ratio is 5. Now, effort how much he has given? Effort is equal to 1000 Newton. Then load how much? Load is equal to 4500 Newton. You have to calculate the mechanical advantage. Mechanical advantage will be equal to load by effort. So load by effort is equal to how much? Load is 4500 Newton by 1000 Newton. So it will be equal to 4.5. It will be equal to 4.5. Right? Next. Now what will be the velocity ratio? Velocity ratio is equal to number of pulleys. Is it not? And how many pulleys are there here? It is equal to 5. So velocity ratio will be equal to 5. Now coming to efficiency. Efficiency eta is equal to mechanical advantage by velocity ratio. Mechanical advantage how much? 4.5 divided by 5. That is equal to how much? 0.9. 0.9. That is equal to 90%. Okay. So this is how we have to calculate all these three: mechanical advantage, velocity ratio, and also efficiency. Understood? Please note down the solution. Next problem. A pulley system has a velocity ratio 3 and an efficiency of 80%. Draw a labeled diagram. Draw a labeled diagram of this pulley system. Next, calculate. What you have to calculate? Mechanical advantage, and then effort required. Effort to raise a load of 300 Newton. Okay. So this is the problem. Now what he has given? A pulley system has a velocity ratio 3. So velocity ratio 3 means how many pulleys will be there? 3 pulleys will be there. So one pulley, you have to draw the diagram very neatly. Now always remember that whenever you draw the strings for the pulleys, always start from the effort end. So this is the effort, right? This is the effort. First draw the effort, then come back, draw straight lines Okay, you have to draw straight lines. You have to draw straight lines, then again go back, then again down, like this. So here load will be there. This is the schematic diagram. How many pulleys are there in the block? Here you see there are 2 pulleys, fixed pulleys, and 1 movable pulley. Now tension in what direction you have to show? You have to show in the upward direction only. Understood? So here also for this string, here also tension will be there. Understood? So here you can see you have to draw the strings from the upper end only. From upper come back. So where the string is coming, the one end of the string is coming to the tackle only. Is it not? So this is the load. This is the schematic diagram required for us. Now what is the mechanical advantage? Mechanical advantage is equal to load by effort. How much is the load? 300 Newton. Right? We don't know the effort also. So what we have to do? We are provided with, see here, efficiency is given for us. Given efficiency is equal to, see, loss ratio is equal to 3. Efficiency how much has given? 80%. Right? I have drawn the schematic diagram. Now using efficiency and loss ratio, can you calculate the mechanical advantage? Yes. Efficiency is equal to mechanical advantage by loss ratio. This implies mechanical advantage will be equal to efficiency into velocity ratio. That is equal to 80% means 80 by 100 multiplied by 3. So how much it will be? 240 by 100. 240 by 100 will be equal to 2.4. So mechanical advantage will be equal to 2.4. Understood? Now after calculating the mechanical advantage, it is very easy to calculate the effort. So this is the first solution. Second solution, effort is equal to load by mechanical advantage. Load is how much? 300 Newton. What is the mechanical advantage? 2.4. So how much it comes out to be? 300 times 3.8 times, right? 8 1 times 8 2 times 16, 8 5 times 125 Newton. So this will be the effort. Okay. So these 2 problem solutions you please note. In the next video, we shall solve 3 more problems on pulleys, mainly diagram based questions.